Good morning, afternoon, evening, whatever time of day you end up watching this. It is time, ladies and gentlemen. It is time for us to transition from expressions over to equations. More specifically, we're going to talk about how to use inverse operations to isolate variables in equations. Now, this is something that most of you will recognize when you see it, because you've probably, studied it in years past. We are going to eventually move away from two-step equations and begin looking at equations where you'll need to use 3 or more steps in order to solve the variables. But I wanted to review two-step equations before we do 3 or more, just to make sure that we are all on the same page. I'm going to tweak this essential question / I will statement. I'm not too happy with it right now, so it should be different by the time you end up watching this video, but the point of this is I want you guys to be able to use inverse operations to isolate variables in equations. Okay, now, what does that mean? Well, so much like many things in life, the 4 base operations that you guys have worked with in math, okay, addition, subtraction, multiplication, and division, these operations have opposites. And in math, when opposites collide, when it comes to operations, when opposite operations collide, they cancel, which means they disappear from equations entirely. Okay, now don't worry about these 2 down here. We will be getting to those eventually, but we are going to focus primarily on these 4 operations up here. Okay, so addition and subtraction are inverse operations, and they cancel each other out. Okay, and canceling out numbers is the name of the game when it comes to solving for the value of a variable in an equation. Okay, and multiplication and division are also inverse operations, and they also cancel each other out. Okay, so we're going to keep that in mind moving forward. Okay, addition and subtraction cancel each other out, and multiplication and division cancel each other out. We won't worry about this until a later date. Let's go ahead and move forward. Okay, so we are talking about equations, ladies and gentlemen. So what that means is we're going to be dealing with algebraic representations that have equal signs in them. Okay, that is the difference between an equation and an expression. Okay, the expressions that we solved in earlier class kick lessons, where we were combining like terms and distributing and all of that good stuff, those were expressions and not equations because they did not have an equal sign. Whereas all of these equations that you see here, the reason that we call these equations is because they have equal signs in them. Now, an equation, okay, is a way of demonstrating in math that everything on one side of that equal sign is equal to everything on the other side of the equal sign. Okay, so if you were to figure out what z is, and add 15 to it and divide by 4, you would get, all of this would simplify out to 4, and you would end up with 4 equals 4. Okay, an equation, ladies and gentlemen, is just like a scale where everything is perfectly balanced. Okay, just the way Thanos likes it. Okay, that, double-edged knife that he had in Infinity War, perfectly balanced as all things should be. We do not want to tip the scales. Okay, if we do not follow the rules of equations, we will end up with something that is no longer balanced, and we will end up with the wrong answer. Okay, so that is why the golden rule of equations is, whatever we do to one side of an equation, we must do the same thing to the other side. Okay, if I were to put, those like unit blocks that you get to play with in earlier grade levels, if I were to put 2 of those blocks on the left side of the scale here, in order to keep it balanced, I would have to put 2 on the right side. Okay, if I were to put 10 on the right side of the scale, in order to keep it balanced, I'd have to put 10 on the left side. Okay, so that is why the rule is, whatever change we make to one side of an equation, we must do it to the other. Now, I will go kind of over this in a bit more detail later on in the video, but there are 2 different types of two-step equations you can run into. Okay, there are normal two-step equations, which are these over here on the right. And then there are the equations that are not normal, because one side of the equation is one big fraction. Do we see in this equation here how all of this right here on the left side is one big fraction? Over here, the right side of the equation is one big fraction. These equations work a little bit differently from the ones here on the right, okay, which are probably the ones that you are used to working with. Okay, see on the left side here, we do have a fraction, but the entire side of the equal sign is not a fraction. Okay, the entire side of this side of the equal sign is not a fraction. Same thing over here. Okay, these work a little bit different from these guys right here. Okay, and again, I will come back to this page in just a moment, but when you are working, be it on ClassKick or on Khan Academy or on Prodigy, if you are going to refer back to these notes, like if you run into, something that's giving you a hard time, you're going to follow the examples on page 5 if the equation you're working with has one side of the equal sign that's one big fraction, and you'll use the examples on page 4 if your fractions are normal, meaning that one side of the equal sign is not one big fraction. I'm going to do 3 examples of each, but we'll start out with the normal two-step equations first. Okay, so we're going to do 3 class examples here. And as always, ladies and gentlemen, if you do not show your work, you do not get any credit. And that goes for the examples and for your independent practice over on page 8. Alright, let's go ahead and do this thing. So, ladies and gentlemen, our goal when working with equations is we are trying to isolate the variable in the equation. So what that means is all the numbers that are on the same side of the equal sign as your variable, we need to cancel those out so that the variable can be all by itself. How do we cancel those numbers out? Well, we're going to use inverse operations. So we will use addition to cancel out subtraction. We'll use multiplication to cancel out division. We'll use subtraction to cancel out addition. And we'll use division to cancel out multiplication. Okay, so keep that in mind as we move through these examples. Now, when you are dealing with a normal equation, where one side of the equal sign is not one big fraction, the first thing that you're going to do is you're going to check to see if there are any parentheses that you can cancel out by using the distributive property. Okay, like this one down here. But let's stay focused on example number 1. So we don't have any parentheses, so we move on to the next step, which is we are going to cancel out any number that is being added or subtracted. And if you take a look at this number right here, okay, this plus 2 is being added. Okay, obviously, that's what the plus sign means. So in order to cancel out this 2, we are going to have to do the opposite of addition, which means that we are going to use subtraction. Okay, now, what are we going to subtract? Well, we're going to force this 2 to turn into a 0, okay? Because when things equal 0, we get to cross them out and erase them, and they disappear from our equation entirely. So, to cancel this out, because this is a plus 2, we are going to subtract 2. Okay, and remember, because equations are like scales, if we subtract 2 from the left side of the equal sign, we need to do the exact same thing to the right side of the equal sign. Okay? So plus 2, so positive 2 minus 2, that equals 0, ladies and gentlemen, which means that it cancels out. And then 6 minus 2 is 4. So on the right-hand side of the equal sign, we have 6 minus 2, which is 4. We just canceled out the 2. And now all that's left on the left-hand side is a divided by 4. Okay, remember that fractions represent division. Okay, so this is a divided by 4, and we need to cancel out this 4, and then a will be all by itself on its own side of the equal sign, which means we'll be done. Okay? Now, this 4, okay, remember, this is a divided by 4. So if we want to cancel out this 4, that means we need to do the opposite of division. Okay? And that means what we are going to do is we are going to multiply both sides by 4. Okay? If we multiply the left side by 4, that means we need to multiply the right side by 4. Okay? All right. And now what happens is, and I'll go into more detail as to why this happens in a later video, but for now, just know that these cancel each other out. Okay? So now on the left-hand side, all we have left is a equals 4 times 4, which is 16. Okay, and now we know that the variable a is equal to 16. And it was equal to 16 this whole time. Well, how do we know that that's the correct answer? Let's go back and check. So if A equals 16, let's replace A with 16 and see what happens. So we're going to replace A with 16. And then it's divided by 4 plus 2. Divided by 4 plus 2 equals 6. Okay, and now we follow the order of operations. So we have division and we have addition. Division comes first, so we're going to do that first. So 16 divided by 4 gives us, let's use purple, gives us 4 plus 2 equals 6. Plus 2 equals 6. And now what's 4 plus 2? 4 plus 2 is 6. So we ended up with 6 equals 6. Is this a true statement? Does 6 equal 6? If I were to take a scale, okay, like in, like right here, if I were to take this scale and I were to put 6 of those blocks that we mentioned earlier on both sides, would that scale still be balanced? The answer is yes. Yes, it would. So that is how we can tell that we got the correct answer. Let's just pretend. Let's pretend that we did the answer, or that we solved this problem, this part on the right, incorrectly. And let's pretend that we got the answer A equals 8. Okay, now we're going to check to make sure that that's the right answer. Okay, so we do the same thing. Take the same equation that we started with and replace A with 8. So we get 8 over 4, or divided by 4, plus 2 equals 6. Plus 2 equals 6. And we follow the order of operations, and we get 8 divided by 4 is 2, plus 2 equals 6, and then 2 plus 2 gives us 4, and we end up with 4 equals 6. Is this a true statement, ladies and gentlemen? Is the left side equal to the right side? If I were to go back to this scale, and if I were to put 4 blocks on one side and 6 blocks on the other, would the scale be balanced? The answer is no, and that is how you can tell on your own whether or not you've got the correct answer. You take it and you plug it back in to your equation for your original variable and see if you end up with an equation that is perfectly balanced. I actually don't know why I did that. Let's see if it'll... it won't let us go back any further. Okay, that's fine. So that's example number 1 out of the way. Let's go to example number 2. So we have 9x minus 6 equals negative 6. So remember, the first step, we check to see if there are any parentheses that, we can distribute into to make go away. And we don't have any parentheses here. So we move to the next step. We cancel out any addition or subtraction that we see. Okay, because remember, we're trying to get our variable all by itself on one side of the equal sign. So we're going to use inverse operations to make this 6 and this 9 go away. So here we have a 6 that is being subtracted. What do we use to cancel out subtraction? What is the opposite of subtraction? Addition. So in order to cancel this out, okay, and remember, we cancel things out by making them equal 0. What we're going to do is we're going to add 6 to both sides. Okay, and what's going to happen is that's going to cancel out, which means that we will have 9x on the left-hand side, and negative 6 plus 6 equals 0. All right. Now we need to cancel out multiplication and division, and then we will be done. So the 9 and the x are right next to each other with no sign in between, which means they are being multiplied. So the 9 and the x here are being multiplied. That means we need to do the opposite of multiplication to cancel out the 9. And what's the opposite of multiplication? Division. So we're going to divide both sides by 9. The 9's cancel out, and that gives us x is equal to 0 divided by 9, which is 0. Awesome. And there we go. Just like that, we've solved it. And now let's check our answer just to make sure that it's good. So we're going to go back to our original equation here. Okay, so 9x minus 6 equals negative 6. Okay, but we're going to do 9, and instead of x, we're going to put 0. Minus 6 equals negative 6. Okay, so remember, these are being multiplied. So what is 9 times 0? Well, that's 0. Minus 6 equals negative 6. 0 minus 6 is negative 6. So we end up with negative 6 equals negative 6. This is a true statement, ladies and gentlemen. And that means that we have proven that x does equal 0. And we know with 100% certainty that we are correct. And we've done the problem correctly. Okay, let's go down to example number 3. And we're going to roll through the steps. Sorry to drink some water for a sec. And we're going to start by checking to see if there are any parentheses that we can get rid of by distributing. And there are. So let's go ahead and do that. Let's distribute into the parentheses. Okay, so 7 times 9 is 63. Plus 7 times k is 7k equals 84. Okay. Now, this is where things are going to look a little bit strange, okay, but bear with me here. Okay? So a lot of students get hung up on, instead of thinking about what's being added or subtracted when they perform the next two steps, students mistakenly always believe that the number that we're canceling out is always in the middle. Okay, the number that we cancel out first is always in the middle, and that is not correct. Okay, we are looking for division, multiplication last, okay, and that's what we have here in the middle. So we're looking for whatever is being added or subtracted first. Okay, and what's being added or subtracted is the 63 right here. Remember, the 7 and the k are right next to each other, which means they are being multiplied. So we're going to save that until the end of the problem. So let's cancel out this 63. The 63 here is positive, so you can think of it as addition. Okay, and if we want to make it 0, what we will do is we will do the opposite and subtract 63 from both sides. Okay, that means that these are going to cancel out. And that'll leave us with 7k equals 84 minus 63, which is 21. Okay, the 7 and the k are right next to each other with no sign in between, which means they are being multiplied. So we need to do the opposite of multiplication to cancel out this 7, which means we are going to divide both sides by 7. The 7s cancel out, and that means that we end up with k equals 3. And we are done, because we now know the value of our variable. Okay, and for the last time in this video, we'll plug our answer in just to make sure that it is correct. So 7, and then instead of it being 9 plus k, we're going to do 9 plus 3, because that's what k equals 84. Okay, we have like terms here inside the parentheses, which means we can add them together. So 9 plus 3 is 12. Okay, so 7 and the 12 right next to each other with no sign in between. 7 times 12 is 84. And that means we ended up with 84 equals 84. Is this a true statement? Is 84 equal to 84? Yes, it is. And that means we have done the problem correctly because our equation is balanced at the end of the problem. Awesome. Okay. So that is the end of the regular equations where one side of the equal sign is not one big fraction. We're about to hit the 30-minute mark on this video. So we're going to do the 3 examples of the, abnormal fraction or abnormal equations, but we're not going to prove our answer this time, just to save on time. Okay, so guys, when one side of your equal sign is one big fraction, you're going to do your steps kind of like in the opposite order of what you were doing in the last problem. So in the last problem, right after we took care of parentheses, we canceled out addition and subtraction first, and then we canceled out multiplication and division, right? We're going to flip those two around this time. And what we're going to do is we're going to cancel out the multiplication and division first. Okay? So, our goal is to get v all by itself, which means we need to cancel out this 8 and this 3. All of this is being divided by 3. So we're going to start this time by canceling out the division. Okay, and what cancels out division? Multiplication. So we're going to multiply both sides by 3. Okay? These cancel. So on the left side of the equal sign, all we have is v plus 8. Okay, and because we multiplied the left side by 3, we have to multiply the right side by 3. And that gives us 21. And now v is almost by itself. We've just got to cancel out this last number here. So this plus 8, what do we do to cancel out a plus 8? Well, we do the opposite of addition, which is subtraction. So we're going to subtract 8 from both sides. And that means that these are going to cancel. And that's going to give us v equals 21 minus 8, which is 13. So v is equal to 13. And just like that, we're done with the first example. Okay, let's take a look at the second example. So once again, we have one side of the equal sign is one big fraction. So we're going to cancel out the multiplication and division first. We have all of this being divided by 4. We're going to cancel out division with multiplication. So let's multiply both sides by 4. Okay, so 4 times negative 2 is negative 8. And that equals, okay, well, these are going to cancel out. And that's going to give us 5 plus x. Okay, and now our variable is almost by itself. It's got one number left that we need to cancel out. So we have a positive 5 here that needs to be canceled out. What could we do to this positive 5 to cancel it out, and make it equal 0? Well, we can subtract 5. Okay, subtract 5. And whatever we do to one side, we have to do it to the other. So those cancel, and we get x equals negative 8 minus 5 equals negative 13. This is where knowing how to multiply and add and subtract, with positives and negatives, you have to be able to do it in order to do these problems. Having the wrong sign will count as having the wrong answer. You need to go back and check those videos and those lessons if you are still unfamiliar with them. Okay, last one, folks. We have one side of the equal sign is one big fraction. Let's cancel out the division first. We're going to multiply both sides by negative 15. Okay, because remember, we're trying to get our variable n all by itself. The negative 15s will cancel. And that means on the left side of the equal sign, we'll have n plus 5. And on the right-hand side, negative 1 times negative 15 is positive 15. Okay, one last number to get rid of. And that is the plus 5. How do we cancel out a plus 5? Well, we need to make it equal 0. It's plus 5, so that means we're going to subtract 5 from both sides. Remember, it's all about canceling the numbers that are on the same side of the equal sign as our variable. Okay, so that means on the left side of the equal sign, all we have is n. And on the right-hand side, we end up with 15 minus 5, which is 10. And there we go, ladies and gentlemen. That is all of the examples done. And if you go to slide 8, this is where you will find the 5 problems I would like for you to do on your own. And if you have any questions, okay, feel free to go back and look at the examples, or you may raise your hand in ClassKick, or you may message me through GoGuardian. Thank you for your attention, folks, and good luck.